everyone, and welcome to another video of CS202 Online. Today's topic is going to be templates. And so templates is a topic that you don't necessarily need, and you so far don't know what it is probably, but you have been using it all along because a lot of libraries that use in C++ contain templates, they're templated. And so the job of templates is not just to make your life easier, but also to make other people's life easier when you're developing a library for them. So there are two kinds of templates that we're going to be looking at. We're going to be looking at function templates and class templates. We're going to start with function templates just because they're a little bit easier to explain, but they're both relatively simple on a sort of like overview basis. They can get a little tricky once you're actually implementing them and you do things like inheritance and whatnot for class templates. But on like a superficial level, they're actually pretty straightforward. So before I show you like an example of a function template, let's kind of revisit what functions are and different things that we can do to functions to sort of expand their functionality, okay? So the first thing is overwriting, right? So day one of the class, or if you learn this in 135, we talked about function overloading, right? And I also brought up the concept of function overwriting. This came around when we were talking about inheritance, right? So what are these in case you don't remember, which I hopefully you do, but if you don't, that's okay. So function overloading is the idea that, let's just say we have a function called foo. And this function foo is just going to do something. It doesn't really matter what it does, but it does something. Let's just say that it prints the number 1 or something. Well, let's see out, I suppose. It just prints a 1, okay? That's all the function does. And let's say that eventually you really like that function and you want to add extra functionality to foo. So maybe you're like, instead of printing out a 1, what if we print out actually what we passed in, like that parameter, right? So now you can do something like, well, you got to give it a name. So maybe the parameter is called x, and so you print out x, right? And so these two functions have the same name, our identifier, which is the word foo, but they have different number of parameters, and that is why there is no confusion, right? If you have two functions that have the same amount of parameters and the same type of parameters, then it becomes ambiguous, right? So the operating system doesn't know which one you're referring to. So if I went and said, here I'm going to make a third function, and I made this function have a double instead, then depending on what I'm calling this function with, it's going to decide, right? So if I call it with a double, it's going to call this code. If I call it with a float, then it's going to have to figure out between them, right? And this comes to distancing and sort of figuring out which function to call based on the parameters, right? And so sometimes it can be ambiguous, right? So for example, if I pass in like a for example, if I pass a string, it's just going to be confused. It's going to be like, I can't find one you can use. But if I had a double and a float, and I passed in the car, that would probably get it confused. Whereas if I only had the integer function and I passed anything to it except for string, it would basically coerce it there, right? So this idea of function overloading allows us to have a function that does a lot of things. Now, why do we want to do this? Well, you kind of have to revisit the idea of compile time polymorphism, right? So what is polymorphism? Polymorphism is multiple forms. It's the idea of being able to have code that can take different shapes, can handle different things in different situations, right? So, if you want to create a print function, you want that print function to be flexible, right? You can pass it in any data type that you want and it still works. However, you need to consider different code for different data types. So you could do something like function overloading, but you're limited by the amount of data types, right? So you have to basically write a function for each data type if you want them to work properly. You might get away with some of them, but you don't have to do every single case, like if you have this coercion situation. But if you start adding custom classes, then you definitely have to keep adding, right? And so you're overloading the function. So that's function overloading. Moving on from there, and of course you can also overload by adding multiple number of parameters, right? So maybe I'll do one more example where you do something like int a and int b, and in this one you have to decide what that does. So maybe that just see out a plus b's result or something. Okay, it doesn't really matter what's in here, but yeah. Okay, so just like I said, multiple amount of parameters, parameter change and the parameter type change. Okay, moving into function overriding. So once we discovered what classes were, we were able to do something like this, right? We write a function, we would write a class called a, and in that we could write a function, like let's say we write a function foo. This function does something. Again, it doesn't really matter right now what it does. And then if we go ahead and use inheritance, and we inherit from class A, we know that class B contains everything from class A, including the function foo. So I could use it. So I could reference and call the function from the parent class foo. But what if I want to modify it? Like for example, let's say that in here, and of course make this public so it compiles, but make this let's say there's an index here, and there could be other functions in this class, right? But like let's just say that this cout's that local variable or class variable, I mean. So perhaps now you wanted to see out that plus also see out maybe a class variable from here, like an int y or something, right? And so in that case, what you do is you have to override the function. So you're not overloading it because you still want to call it with dot parameters or with the same parameters, but you want to modify what it does. So in this case, you're not just overloading, you're overriding it. You're completely replacing it in this inherited class. So any b that you make is not going to be able to do this. It's going to instead run this one here. Okay? And so you do that by just writing the function name, and then let's say this one is going to see out x, but it's also going to see out y. And so on, right? So this is overriding. So you're sort of enhancing it. Typically what you end up with this overriding is you probably add more things to it or tweak things based on the modifications of the derived classes, right? So like if it's a print function, you might want to print out additional variables that this has, plus all the parent variables. So that's overriding, and it's very useful. One warning with overriding is that if you are using pointers, right? So when we talk about virtual functions, if you're using pointers, if I make a pointer of the parent class here, so like if I say something like, let's just say we do something like ptr gets new b. So we have a pointer of a parent pointer pointing to a child class, child object. And you might need to do some dynamic casting in here for this to be running nicely. But the point is that if I do this and then I go ahead and say ptr foo, who's it going to call? Ghostbusters? No, it's not going to call the Ghostbusters. It's going to call the foo from A, actually, which is not what we want probably, because this is really a B. So we want to call the right function, right? So just like I kind of hinted earlier, we talked about this when we talked about virtuals, because adding the word virtual is what solves this, because then it gets added to the B table. So actually it knows to call the correct function, which in this case is this one, because it really is a V object, right? And this is truly polymorphism, right? Like function overriding itself is compile time polymorphism, but using virtuals in combination with overriding, you achieve runtime polymorphism, because it's at runtime when it decides what this really is, right? So it's very cool. And so again, these things are not things that you like have to have, but they just make your code better and easier to read, easier to work with, and just nicer, right? So being able to have these functions that do multiple tasks, but still use the same name to make it easy, right? Like, so like a function called print is going to print, and you don't have to worry about how it works. It just works with whatever you feed it. It's like cout. You don't need to worry about how cout works. If I say cout2 like this, That's the same thing as this in terms of like, it just prints out a 2, right? But it handles it. It works, and it doesn't complain as long as you feed it something good. So that's the idea of having this flexibility with functions and operators and things like that. And so you just learn about operator overloading, right? And so the ability to also have flexibility with operators, so you could do something like a plus b, even though these are classes, and still be able to have a result because you overloaded the addition operator for that. That's also that compile time polymorphism and adding flexibility. And so templates is going to jump in now into this and sort of extend this further. Okay, so going back to seeing more about like function overloading, a lot of the times when you're doing your overloading here, like let's just say we're doing a function to add 2 numbers together. Okay, if you're trying to add 2 numbers together and they're both the same data type, then you can just just make an int function that has the parameters like this one, the bottom one that we did here, and you're pretty much good to go, right? If you feed it floats, it'll work, but you're going to lose accuracy if the floats are actually like have decimals like at the end of the number, not whole numbers. So you would have to write a float function, right? But ideally, you probably want to do a double function so the float gets casted to a double, but even that's kind of risky and not ideal. You could do that and be okay with it. And then if you want to do something with strings where like you add 2 strings together, that one's not going to work because it won't coerce a string into like an integer or a double, right? So you have to write a separate function for that. So you'd have to kind of add it to the list of things here. So you have to do something like void foo string A, string B, and then you have to figure out what that means. So in this case, maybe what you want to do is concatenation. So you're still just outing A and B, right? But the issue with this is you have to keep writing every single scenario possible here. And it's a pain, particularly when if you overload, so like let's say you have your class A from down here that we made a class A and class B. If you wanted to do an like class 2, add 2 elements of class A, you still have to write another function, pass in the object, so we'll call this A1 and A2. And even if you already overload like the addition operator for this to work, you still have to write an individual function for each scenario, right? So even if you already overloaded the addition operator so that it works in this addition, you still have to do this. Now, if you haven't overloaded it, then sure, you actually have to modify this code and do whatever that means. So like maybe you're adding the x's in it. So really this becomes a1.x plus a2.x, right? But if you overloaded the addition operator, you don't have to do that. You can just stick to the top line. So what I'm trying to get to here is that these last 3 functions that are shown, so this one, and this one, they all have basically identical code inside, which is just cout, variable 1 plus variable 2. In fact, if, I named A1 and A2, but if I just called them A and B, then they would literally be identical, right? And there's a lot of copy pasting involved if you're trying to code this. This is where templates come to the rescue. With templates, you're only going to have to write 1 function example code here, and you will be able to achieve all of these 3. So you're basically going to combine all these 3 functions into one nice and lean function that will save you time, will save you coding in terms of like space, and will just be nicer overall, like clean. It's like oof. It's always nice when you make something that would otherwise take 100 lines of code. You do it in 5 lines, and you're just like, so smooth, right? So yeah, that's kind of what templates are going to help you do, at least on a superficial level, And then things start breaking, and you panic, and you're like, I should have just done it the long way. But no, you're going to get it right the first time, right? So okay, so let me show you the syntax for how function templates work, and then I just want to jump right into the computer to code a couple of them, because otherwise, writing them by hand, I mean, it's funner to see the code run. Okay, so let's really drop. Need some water. Okay, so again, we are looking first at function templates, as you've seen. everything here involves functions, except for that little thing with like classes, but this is still function templates. So the syntax for function templates is going to be the following. It looks weird, but you have to write the word template, which is a reserved keyword in C++. Then you are going to write this less than symbol. Then you have two options actually here. You can write the word class, or you can write the word type name. They are not actually the exact same. There's a slight variation between them. I'm not going to get into that nuance. You can Google that on your own. So otherwise, just, don't worry about it. And after that, you have to put some identifier, which is going to be whatever you want your template to be. Again, I'll explain that in a little bit. I'm just going to pick the letter T because T for templates sounds cool. And then you're going to close this symbol with the opposite greater than and less than symbol. And then this is just in its own line. Well, C++ is white space insensitive, but it's nice to just put that on its own line. And then the next line, you're going to write your function, okay? So if your function is a void function, for example, then you can do that as a return type. So I'm just going to kind of put the word return type here. And by the way, just like with value returning functions that can return like a type, you could actually return a template type. So we'll see that in a second too. But just think of this for now like the word void. And then you want your function name. So like foo or whatever. And then from there, you're going to have your parameters. Your parameters can be any type that you want. But typically, if you're working with a template function, you want them to be template variables. So in this case, let's just say we have two template variables, right? Because we're trying to show you like the addition one. So it's going to be like TA and TB. So in a way, you can think of it like a class, and this is kind of where the word class is there, right? You can think of this like being its own little data type, which is a templated data type. And that's why this T is here, okay? So this could be whatever, if this becomes an F, then these become Fs too. Or at least you should make them F so this works. And then you just write your function like normal. So, function body, which could be something like return A plus B. Okay? And then you close your function. And this is it. So in the case of the addition, it's going to look like follows. And then we'll hop on the computer to start coding it. Shoot, I left it like an F. Get rid of thing. Okay, well, they're all going to, no, I want it to be T. It kind of looks weird as an F. Hold on. Let's move that out of the way. Erase the line. Bring it back. Hopefully no one's bothered by that little dot there. I know some people might. I'm slightly bothered by it, but yeah, it's okay. All right. So class T. And then let's just say we want to return the result of the addition instead of couting it, I guess, because I wrote return there. So, in that case, let's make it a templated return. So I can put a T there. Foo, TA, TB, or not TB. That's the question, right? A plus B. And return it like that. Okay, so that's an example of a templated function. So if this looked really foreign to you with all the symbols and stuff, I'm just trying to show you kind of like the sections of it, right? So the return type, the function name, the parameters, function body, and so on. But this is what an actual templated function is in the wild. So what does this do? Okay, so this is like, as the word implies template, I want you to think of it like a blueprint function, like a blueprint of a house. Maybe let's just say that's why I wore blue today, because blueprint, right? It's theme. So, basically, like, what we are doing here is you're sort of telling the compiler, like, hey, what's up, compiler? I want to make a function, but, like, I'm not completely, like, decided yet on what the types are going to be. So I just want you to kind of put a placeholder for them until you actually see a function call. And you're going to see it while it's compiling. Like, this is the important thing about templates. it's compile time. So all this sort of template stuff is resolved before the code is even finished being compiled. Now, what do I mean by that? What I'm saying is that if I want to call this function, I need to write a function call for it, right? Somewhere in my code. And that is going to look something like this. So like maybe I have an int a and an int b, and I can do something like foo a plus, well, ignore the plus, it's a comma. Something like that, okay? I could also do a function call with something like this. I think this one will work. It's going to be weird, but it should work. It's going to do the ASCII math probably and add those two letters together, I think. I'm not 100% sure. We can test that in a minute. But I can also pass in something like this, 3.7, 4.1. So what happens is when the code is looking from top to bottom, it's compiling your code, it looks at this and it says, okay, you're making a template. See the word template. You have a template variable called t, which is going to be like your placeholder. And then you see that it's a function that returns this type. So you're like, okay, it's going to return whatever this is. Then it's going to be called foo. Make sure that there's no issues with ambiguities or things like that. And then it sees the t. And it knows that this t is coming from here, which is also shown here. And it's saying that whatever this type is going to be, it's also going to be the same thing here. So what templates don't do is this TA and this TB here, they have to be the same type. I haven't told you what type it is yet. I haven't told the compiler what type it is yet. It could be integers like you've seen here. They could be cars, flows, whatever they can be, whatever. The compiler doesn't care so far. All it cares about is that they actually are matching types. Now, what if you didn't want to make them matching types? Well, you can actually do a template function that has multiple template variables. For that, let me just copy paste it down here. You modify this by putting in a comma here and adding like a second template variable. And so now maybe this one's going to come from that one. Okay? So in this case, now it knows like, hey, this is a template and it's matching these two. And then this is also a template and it's only matching this one. They could actually be the same type still, but they don't have to be anymore because it could just happen to be that maybe this is an integer, this is an integer, but they don't have to be. It could also be that like this one's an integer and this one's a float. Okay? All that matters is that they are going to be the same between here and here and between here, here, and here. I'm not going to set that, but like this one, this one, and this one. That's what I'm pointing to. Okay? So the compiler sees that, and going back to the easy one up here, and it's like, okay, so you are going to have this function, and I'm going to assume that this data type exists, this magical T data type exists, and I'm going to check the code to see if it will compile, assuming that this data type existed. So the kind of checks it's going to run is, for example, it's going to look at well, first of all, if like names, like if you randomly pull a C in here, it's gonna be like, what the heck is a C? I've never seen a C before, right? So it's still gonna do the compile time checks that it does. But when it gets to a line like this one here, A plus B, it's going to kind of defer that. It's going to be like, okay, this is valid code, assuming that the operator works with A and B. Now, it doesn't know so far if it will, because it doesn't know when it's looking at this part of the code initially what the types are. It just needs to know whether this is valid syntax, and it is, as long as this operator works between them, okay? So this is the kind of checks it does, and then it just stops. It kind of just says like, okay, that's good enough for now, and I'm gonna just kind of let that kind of chill, basically, okay? And if you don't ever use that template, then this will compile just fine. When it sees in the rest of the code a function call, like this, then it's like, hey, okay, he's doing a function call to the template. So now, and again, this is all happening in compile time. So now it's like, okay, the function call has to already know the types. Like that just has to be given. In fact, if you somehow manage to give it not a type, you're going to get some nasty errors. Which is where templates start to get complex. Because like if you have a templated function call another templated function, then you have to, it's like trying to like backtrace and figure out what the type is. And that's where you can start to have headaches with templates. But we're not there yet. We're keeping it simple. You just have a function with data types that are defined, call the template function. As you can see, the function call looks like any other function call, by the way. You would not know from the function call on its own that this is a templated function, which is why you have been using templates so far, even in 135, but you just didn't know it because it's difficult to see. The one case where you definitely, should have known that you were using templates but didn't because you didn't know the syntax of templates is with casting, right? With casting, you see the less than and greater than sign, right? So like if I'm doing a dynamic cast or a static cast, the syntax for that is like dynamic cast, I don't know, let's just say we're casting to like some A object, a B, right? So in this case, check this out. It's like you're using this template syntax, okay? This will make a little bit more sense once we get to class templates. But yeah, you have been using them all along, okay? Just so you just didn't know it, so now you do, and then you can kind of keep an eye out for that and fix some errors that you might run into that you otherwise would have not known what's up. But anyways, going back to this, these function calls do not look at all like they're calling a template function. But from the compiler perspective, when it sees the function call, what it's going to do is it's actually going to look at the types. So in this case, it's going to look at this one and be like, okay, what's A? Well, A's an integer. What's B? B is an integer. Okay. So now it's actually going to go back to the template function code. It's going to plug them in. So it's going to plug them in and say, okay, T is now an integer. So wherever you see a T, I'm going to replace that with the word int. And then I'm going to check if the code is still valid. And so now it's going to do the checks and it's going to say, okay, can a function return an int? Yeah, sure, that's pretty legal. Okay, so this is still good. Can I have a parameter called, can I have an int parameter? Is that okay? Yeah, I mean, I don't see why not. Okay, this is kind of the first real check. I'm looking at a second parameter of this type. Because they're coming from the same T, does that work? Does they match? Are they both ints in this case? Yes, they are. They're both ints. Okay, so that's a big check that you have to pass. Make sure that you're still using the same type. If this was a float and an integer, then this would give you an error. Be like, that's impossible. Yeah, it just can't happen right now. You would need something like this, right? So it's going to do that check. And then it's going to look at the function body. And now it's going to look back at this A plus B. Now it knows that A is an integer and B is an integer. It doesn't know what the numbers are technically at this time. The compiler, it just knows it's a number. If it knew what the numbers are, the app's pretty much running the code at that point, like doing the calculations, right? It just knows that it's assuming that whatever number there is a number. That's why you can't check for things like out of bounds or overflow or underflow of numbers when you're compiling usually, just because it doesn't know what the computations are giving back. It just knows that it knows and assumes that they're actually integer values because that's what you passed in. So it looks at this and says, okay, I'm taking an integer and another integer, and I'm using a addition operator between them. So it goes look into its record of what the operators can do, and it says, hey, can I basically add two integers with the plus symbol? And yes, you can. That's part of built-in. So it's like, okay, it passes. It passes the checks. So the function call is good to go. It keeps compiling the code. And it actually stores. You could think of it stores as a version of your template code with integer in there. So like it builds on the fly like your foo function with the integer parameters plugged in. Next, it looks at the other one and it sees that it's cars and it does the same checks. And in this case, the T is a car, so it checks everything's okay. It's going to try to check to see if you can add two cars, which I think you can. We're going to find out in a little bit here because I think it makes sense that you're adding integers, but who knows? It's some weird C++ thing, so we'll see. But yeah, as long as that's okay at compile time, then it'll let it slide. Finally, it gets to the floats, and the same thing, it plugs in floats and everything, and you're good to go. One way to run into a problem. Okay, suppose that you're feeding it a class A, and that's what you're passing in, like some class A, which is where's our class A that we've been talking about? This one, right? So like we're passing in that class A. So now, when it does the checks, as long as both of these are class A, that's okay. But when it gets to this line, this operator, it needs to look up and see if this will work, if you're able to add two class A's. By default, that's not built in. So if you haven't overloaded the addition operator, this will give you an error. And it'll be the same error you would have gotten if you written the function where these were class A's. And like, you know, you actually just wrote like foo, AA, and then AB, and so on. So like if you literally wrote this function here, you know, you get the exact same error from this one as you would with the templated one if you haven't overloaded the addition, right? And that's a different story. You talked about overloading, you know how to do that, and so on. So the idea though is that, look, what we would have otherwise done in 3 different functions can be done in one single function. That's templated. That's the power of templates. You see that? So you are able to do what could take you an infinite amount of different variations of parameters with one single function. That's pretty cool. Now, you know, with the asterisk that whatever operators you use inside have to actually work. Otherwise, you know, you run into other problems. So there's no free lunch per se, but it's still going to save you a lot of time and make your code very, very flexible. If you know what vectors are, if you've used them, then you know that you're able to store whatever you want, and you don't have to worry about the data type of it really, because vectors are templated. So it just takes whatever you want and it works. So yeah, that's function templates for you. So let's go ahead and code a couple and let's see if this will work with the car and show you a little bit of the things to look out for when you're dealing with templates, because you know it all sounds nice and cool. Everybody gangs that until you start doing inheritance and templates and the code gets really nasty. This is a meme, right? So yeah, actually I think that's actually like you can find a picture about that, like knowyourmeme.com or something. But yeah, in fact, I would say if you go on any of the meme websites, and they're talking about like things that they're making fun of C++, templates is like one of the top things that people complain about, because they get really nasty when you actually start using them in like real code. Because when you do inheritance and other things, you have to keep track of templates, and you'll see even the syntax of the code is just like, it gets really nasty. But for a basic thing like this, they're like, oh, super nice. And when they're working, like I said, everything is nice because you can actually, the user doesn't see that you're dealing with templates. It just knows that things work, and like it's great. It's that abstraction of the code. But to get to that stage is not easy. So yeah, I don't like the camera. Like, I got a new camera, but like I need to recenter it. I'm kind of cut off here. My Harvey Dent. All right. Okay. So let's write a template. And then let's do the same one because we want to test with the card. I'm going to just do, I'm not going to use A and B because I have that class A and B. I'm going to use V and Z. How about that? Okay. And then let's just make that one class that we had. Or actually just a class, A, that has like an int X. And then make a class B as an int Y. That'll come in useful later. Okay? So we want to return V plus Z. Okay? So yeah, I mean, that's pretty much it. If I go in here and I say foo 1 comma 2 and then see out the result of that, this should print out 3. As you can see there. Let me add an end line so it's easier to see. Case in point, right? So I mean, that's cool. But now let's change this to something more interesting, like a float. That should be 5.5, and you get a 5.5, right? So you could have done this without templates. Like you would have to write 2 separate functions. You could have written one with like doubles, which would have been handled the integer case without losing accuracy. Yeah, I mean, like, you're dealing with like give and take issues. And if you wanted to force it to be integers, then you couldn't do that. What you cannot do is mix and match, right? So let's see what happens if we do this. See if it takes out of complaints. Nope, it does not. It looks like it ran, but it didn't. We get errors here. You can see no instance of function template foo matches the argument list, right? No matching function call for a double and an integer, which is what you're passing in. Because yeah, it can only do when they're both the same type. So as you can see, if you wanted to do that, then we'd have to make either another template function or modify this one to have the second use the letter after T, of the alphabet. Then you could do something like this, right? And then it would work, but you have to understand the difference between them. One of them is requiring them to be the same type. The other one is allowing them to be different types. You better make sure your operator overloading is like prepared to handle that scenario where like the way I wrote this code right now, I could call this with a string and a car, and then or a string and an integer, and you better have that prepared in terms of like that working. So they're different. They're inherently different functions. You just need to make sure that you're aware of that. This is nasty. This is already starting to get nasty now. If I do this, because I'm overloading a template function, which I think is okay, but that starts to become a little scary. I'm gonna have to like see out who's getting called now. I'm gonna call this TU. And then I'm gonna call this TT. Okay. Let's just do T. Okay. All right. So yeah. So if I do this here, instead of erasing that, I'm just gonna leave a couple in there. Let's do 2.1. You can see that it's gonna call different ones. So this one calls T and this one calls TU, right? They both give me 5 because why did they give me 5 actually? There's probably coercion going on. Let's look at it slowly, or we can just run the debugger. But so this one it gives you 5 because yeah, it's just calling this one and they're both integers. This one, my guess is that the integer here, even though the other one is being passed as a double. Oh yeah, because the return type is a T, right? The return type is the integer. So even though this addition probably like keeps it as a double, then when it returns as an integer, there's that coercion happening. So if I switch this to be not this one, but this one up here, to be a U, and I think I should get the 5.1, because the integer addition is like an integer plus a double. It like the result of that is a double. It doesn't like coerce the double into an integer. In fact, it sort of coerces the integer to a double, right? So yeah, as long as I return the double, then it keeps that. But before I was returning an integer, which is coercing it back, and losing precision. Over there, you can kind of start to see the nuances of this, right? So this is a different type than this and this. So it needs to be able to, like, you need to know, you have to realize that is happening. Otherwise, like, it's a bug waiting to happen, right? Now, could you make that a completely different type? I mean, I don't know. I don't think that would work because you never define what that is anywhere, and it's impossible unless, like, here you do something. Yeah, I don't think that's horrible. I don't think that should work. Yeah, it just gets confused and like it's like I don't know what's happening. So yeah, if your return type is its own data type, then in this case that's probably going to be a double. I guess I don't know, like, so I'm calling it with an int and a double, and then when it feeds it in here, int and double, no, it's just really scary at this point. I don't even know. Like, I can compile it as long as I don't call the function. But the moment I try to call that function, it's just going to run into problems. So yeah, keep your return type at least one of the types that is passed in, so that you know what's happening in the code. Okay. So yeah. Oh, I went too far. Okay. So now let's go ahead and try the car one. I'm curious now. So let's do like an A and a B. Okay. So it returned to me some weird unknown character. That's fine, because probably what's happening is I am adding the ASCII equivalent of an A and a B, and that's probably like somewhere in like the high 100s. Let me pull up an ASCII table from ASCIItable.com. I'll show you. So A is 97, and so it's A and B, I said. Yeah, A and B. So 97 plus 98 is just getting added essentially, which is going to be 195. So that's obviously out of bounds. But if I do something like maybe let's do 50. No, that goes out of bounds too. What's like a small ASCII that I can pass in? 33. So let's do 33 and 33. Actually, I could have done 50. 50 plus 50 is 100. So yeah, let's just do 50 plus 50. So 2 plus 2, but with ASCII. So if my calculations are correct, we should get a D. And we did. See that? It's all about the ASCII math. So of course, when it goes out of bounds, it's giving us that weird question mark. It's confused, right? So yeah, cool. It's not complaining. So nice. I mean, that's kind of what I expected, but you know, with C++, you can expect things, but until you try them, then you'll really know if things work and no. So yeah, let's try the string one. Let's see what happens with the string. Will it concatenate? Will it give us an error? Invalid operands with type const. Oh, const car. Is it that? I'll try it. Let's see. It's thinking these are character arrays because they technically are, rather than strings. That's what the const car pointer is. It's pointers now. So there's a const car array. So it's a car array that's made of const. So there's no concatenation for that. There's concatenation for a string, but not for arrays, unless you overload it. Which, could you overload that? I don't remember. Try it out on your own. Let me know on the comments. But yeah, if I actually pass strings, then it's okay. And I lost it. Here we go. Hello world is here, as you can see, right? So yeah, it works with concatenation. So all with one single function. Well, I have two of them, but I'm using everything here except for the one where it's different data types. So yeah, and technically I could erase this one and everything should still work. But like I said, you just be careful. You have to know what's happening. Otherwise, you're going to run into serious problems. Okay? I didn't want to add a plus. Not plus, a space. Bothers me otherwise. So, yeah, that is it. That's your function templates. They make your life easy, and they can really simplify your code. I'm going to stop here because I want to talk about class templates now. And then we're going to kind of go further, like I said, because things do get kind of nasty with function templates. You already kind of got a taste of it with a return type. But for now, I will stop there. And yeah, let's cover the second half of the equation. And then we can actually really start exploring templates and doing scary operations with them. So let me save this. It's going to be 13. So you can download, remember, you can download these from Canvas. So that you can play with the code yourself. That way you don't have to try to take a picture of YouTube or something. So yeah, okay. So we talked about function templates and how they can make our life easy and improve our code. They actually, I would say, improve a little bit of readability when you don't have to look at 50 different functions that have the same name and different parameters, and you're like, oh, particularly like updating them, right? Remember, like the whole thing with inheritance is like you have a base class that you can update, and like it propagates all the updates to all the children. It's kind of, think of it the same way with function templates. Like you need to fix a function template code, or you want to add something to the function, and you only have one. That's it. You just update that and you're good to go. If you copied and pasted 50 different functions called foo, you gotta go in all 50 and update them, and that's it's not fun and prone to issues. So yeah, that also stands the ability to have easier updates. It's just that like with great power comes great responsibility, and templates are a lot of power because they can do a lot of things. But the cool thing again about templates is if it compiles, it's good, really, because like all the checks are done at compile time. So like you're never gonna have a situation where like a template function isn't checked if the code and the operators work at compile time. It will always be checked, and you'll always know if you have a bad function call. What you don't know is you might have an issue in your code, and if you don't call the template function with the issue parameters per se, then you won't get an error. But then again, technically you're not running into an error because you never called it with the problematic scenario. So that's a good thing and a bad thing, but I'd say it's more of a good thing than bad, because like I said, you know, as long as the code compiles and you don't get any weird errors with the templates, then the templates are secure and safe per se. It's only if you were writing bad code that you would get the error, and it's good that you get it at compile time before, you know, it's out in production. So yeah, okay. Moving on again to class templates. So the other half of the equation per se, when it comes to templates, are going to be class templates. So what do class templates allow you to do? In the most basic sense, you know, if I'm writing a class, and I have already, but like let's just write another class A. You know, I love class A. It's like if you did a survey of like for all the classes that I bring in this class, like the name of the classes, I think A would be like up there. It would probably be like a bell curve, or actually no, it would be like that, right? So and then like here, this would be like the majority of the classes class A, and probably class B, and then maybe like XYZ or like UBXYC. Like I don't even remember if I ever written a class called E, like ever. Maybe I should. Nah, we don't like E's, I guess. It's too far in the alphabet to remember it. Okay, so yeah, our class A, we are going to go ahead and just put a variable in it, you know? Put a variable and put a function in it, like we did before. So we're going to call our variable, hey, let's be bold. Yeah, why not? Break the pattern. Int E. Ooh. Okay. And then let's make a function that also is not foo and bar. Let's call it see, already I'm like thinking like, what do I call it if not foo or bar? Car. Okay. All right. And what does function car do? It's just going to see out, or just make it like a getter function. Yeah. So forget the originality. Call it getty. Make it a value returning function actually too. Or no, I want to do that eventually, but not yet, because that's going to bring in function templates to the equation, and so on. So yeah, for now, I think we'll just have an empty function. Yeah, this is good for now. I want to keep this as simple as possible to focus on the template part of this. No confusion with other things yet. Okay, so we have our function of class A with an int E in it and a function car, and we know that this function is amazing and we love it, so we want to make a second function out or second class out of this, but we wanted to use like a double. We want to upgrade because it wasn't accurate enough within this here, right? So we make a class B. We can't really use inheritance for this. I mean, we could, but like if you're trying to add another variable, you're going to have like a useless E if you're not going to be using the int part, if you want just a double, right? So you really have to make a brand new class. And now you can call this one double E. Right? And then you're like, oh, this function, this class is amazing, but I also want one for strings. And you're like, okay, fine, class C. This one has a string. Right? And like I said, there's really no way that you can use inheritance to like make your life easy. Like you're just kind of stuck with just copy pasting, right? And let's say you needed to do like custom variables, like let's say that you actually want to make like you have a class D that's just like something else, and you actually want the E variable in here to be that class D. You have to again make another class, right? Let's running out of letters here. So let's say we have a class. So let's say we have a class D, and what we actually want this variable to be is of A's. Kind of trippy, but makes sense, right? It just means that there's an E in there. Or sorry, there's an A in there. So like, technically there's an E in there, but it's in the A, right? So all of this is being put in here, basically. That's composition, right? So yeah, ultimately what I'm saying is you have to like literally copy paste, warm up that Control C and Control V because you're gonna be copy pasting a lot. Just like with functions, right? This is the issue that templates will solve. We're not gonna do any copy pasting because we can do a templated variable inside a class. So this E variable, we're gonna convert it into a template. And if I had really high-end graphics here, I would put all these and like merge them together. So like animation, like ooh, they're all gonna combine together and form. A brand new class templated. Be a cool animation, but it's not worth the time doing that. Too much effort. Better spent doing other things. Okay, so yeah. Let me show you before I show you that. Let me show you the syntax again of the template class, and then I'll show you how to do that. Okay, so just like with template functions, you still got the word template, and then you can use instead of class the word type name here. Again, there's a slight difference. Don't worry too much about it now. You'll never run into the issues in this class for that, at least. Google it if you're curious. And then leave a link on the description below, because I actually, off the top of my bat, like I remember there's some issues you run into with type name. I think the type name comes from like the C days. Yeah, it's been a while. Type name allows you to do things like to alias like a type. I think you can do something like this with type name. It's been a while, but like you can do something like, no, actually the other way around. So what you're doing is you're basically, well, let's just something else. Let's call this number. I think you can do this with type name. And then what's happened is like anywhere where you would use the word int, you can use the word number. So if you want to declare an integer, you can do something like int a, but you could also do something like number a. And these two lines are identical, technically. That's what type name does. In the case of templates, type name takes the same role, but there's a tiny difference somewhere. So yeah, Google that and figure out. Let me know. It's been a while. At some point I knew it, but there's just so much stuff about it's like so much stuff about C++. You just can't know everything. If anybody tells you they know everything about C++, then you shouldn't trust them at all because they don't know anything. It's like the thing, the more you know, the more you realize you know nothing. It's the kind of thing that applies to programming languages. So yeah. But anyways, they should know some template basics though. Otherwise, they really know nothing. But yeah. So template, class T, And then because this is a template class or a class template, you're going to write the word class here. I guess in theory you could do the word struct, but stick to C++ syntax. And then you're going to put your identifier of your class. So I'll just, this represents the identifier. And then start your class, close your class down here. And then anytime that you want to use that template, then you just go for it and use it. So like, you want to make a variable, then make the variable. Give it the variable some identifier. You want to make a function, just like a template function, then you go for it. For like return type, which could be the template, function name, parameters, which could be templated, and then function body. And so on. So yeah, this is what it looks like. Now let me show you what it looks like in this specific case. If we want to combine all of these. So for that, what I'm going to do is, actually let's copy the first one. I'm going to just start with the original code and then modify it to make template class. So the first thing I'm going to do is I got to write that fun code in the top. Yes, it will get a little repetitive after a while. To write that again, it doesn't have to be the same line, like a different line, but it's just nice this way. Make your code look nice. Take pride in your work. So do that, and then let's say you want to make the the template variable. So then go ahead and do that. Then you're done. Voila, templated class. Congratulations. That's all there's to it, really. Like, again, on the basic level, this is really easy. It starts to get nasty with inheritance and other fancy things, which I'll show you. But on the basic level, that's all there's to it. You just literally write this code on the top, and now replace whatever you want, your variable, with a template, just like that. So yeah, let's just go ahead and just jump right into code it. Because the stuff we have to test it. I'm scared to claim something and then it doesn't compile, so yeah. Okay, so let's clean up since we backed this up already. And yeah, let's make a template. And okay, so that's the same code. I just copied it from what we just wrote. And I forgot one important thing to tell you, actually. So now that you made a template of class, how do you actually instantiate it? How do you create an object of it? So you might be disinclined, because I didn't say anything, to be like, oh, well, if I want to make an A in main, I just do AA. And then you just call it a day. But that won't work, actually. Big issue with this. So think back what I said with function templates, right? So with function templates, the code, all the checks have to be done at compile time. So it looks to see if the syntax is okay of the function, and then until the function call, does it try to plug in the types based on what the function call parameters are, or arguments, right? So it kind of has a similar sort of logic happens with a class. So with a class, when the compiler is checking it, look at your header file or whatever you have, the stuff, it's going to look at the code, and it's going to sort of just check to see if the syntaxes are good and whatnot in this pass. It's just going to see, okay, you're making a template. It's, the variable is t. You have a class A. You have some functions. It checks to see, things like semicolons and curly braces are matching and all these kind of things. Parameter, variable names, types, all that stuff is being checked. Then it gets to the variable here. It sees a TE and it's like, okay, this is a template type. So is this legal? Yes, I will make it legal. Yes, it's legal. If you have a function in here, then I would check to make sure that's okay. If you have similarly, it will defer things like checking operators and things like that because it doesn't know at this point, well, this is what type this is. It's an integer, a float, double, a custom class. It doesn't know. It's just checking those basics then. It goes through it and it's like, okay, looks good so far. And that's all it does. Until it gets to the instantiation. So if you never make an object of this class, then that's it. You're good. You could have errors potentially in your logic, semantic errors, but syntax errors you don't have. Otherwise, the compiler will stop you. But when you go in and make an object, that's when it finishes doing the checks. Because the moment you try to make an object, the line of code like this, the compiler needs to know right there and then what the templated variable is going to resolve to. And what that means is it needs to know what t is. Is it an integer? Is it a double? Is it a string? Is it some class X, class Z, whatever? It needs to know then so that it can run the checks again and see if with that data type the code is still valid, the operators work, and so on, just like with functions. So if you just write an instantiation like this, you're not telling it anything. Like, what is this? Is an integer, a float? Like, what is this? And if this worked, then if I did something like cout a.e, then this would even be worse. Like, how? What is this? Like, what is this? An integer, a double? Like, what's in there? Or, if I do something like this, you might be like, oh, well, this is kind of obvious that this is an integer now. Well, no, technically that could be a double for all I know. So there's no way that you can sort of decide at that time what the type is unless you actually explicitly state it to the compiler, and you're required to in C++. And the way you do that is when you're creating an object of this class that's templated, you need to add the following syntax. So let's write the syntax with the syntax rules up here. So instantiating a templated class. So what you do is you write the class name, then you put the less than and the greater than sign, and in there you need to resolve what the templates are going to be. So the template variable is resolved to there. And then you can go in and write whether you're making, the identifier of the template you want to make, or if you're making a pointer, then you can do the pointer and then identifier and so on. What this means for this scenario is if I want to make this e be an integer, then I have to write the data type there that I want it to resolve to. So the full line of code will be this. If I want it to be a float, then I gotta put the word float in there. If I want it to be a pointer, what does I want it to be a pointer? You can't make it a pointer, but what kind of pointer is it? Is it a void pointer? Probably, hopefully not. So maybe you want to make it a string pointer. Sure, we don't really do those a lot here. So you make it a string pointer, just like that. So you have to define the type. Now this kind of revisits what we were talking about with the casting, right? So like this is where the where casting comes into play. So when you're using your casting, what is happening when you're doing a casting call? So like if you do something like this, what's happening here is you're making an object. So it's kind of like creating a templated class. The class is called static cast. The template variable is being resolved to an integer, and the constructor parameter is the value that you're trying to cast from. So in this case, a 2.5, which is a double. Remember, anything with decimals in C++ is a double unless you put the F in front of it. So if I put something like this, then yes, it is now a float. But otherwise, it's assumed to be a double by the compiler. So yeah, that's where the syntax comes in. So, if in 135 they were talking to you about casting and you saw the syntax and you're like, what the heck, why? Like, why don't they do it the C way, where they just, do something like this and then call it a day? Well, that's because we are using templates, and that's the syntax for templates. Embrace it. Embrace the meta of C++. So yeah, just a little fun fact. Anyways, now that I show you that, kind of important, let's go back to the code and do some examples. Okay, so let's create an object of class A. Let's start with an integer. And you can see the autocomplete is already having the word type name there, so that's neat. And let's just call it U. Let's make another one, and this one let's make a pointer. It's V. Let's make one that's a string. And then let's make one that is, what else could we make in here? Well, what we can't do right now, because we only have one class, is we can't make a class of a class. That's going to give us an error, but let's actually take a look at that error. So it's a good error to take a look at. Although, what I could do, well, here, I want to show you the error and then show you what we can do. So let's just run it so we can see that error. So argument list for class template A is missing. What is happening here is I'm saying I want this to be the type of whatever the class A is, but class A itself is a templated class, so you can't just make it out of that. What I could do though is I could put, it's like inception, template inception here. I could do something like that, and then it runs just fine. So what is happening now is I'm saying, okay, I want to make a class A, and the variable E is actually going to be a class A of itself, but that one is of an integer, and that will work fine. But that's kind of trippy, you know. At least to me, it's like, huh, okay. Let's put some spacing to kind of make it easier to see. Like that. Okay? So really what is happening is we're saying we're making a Z, and that one is going to have a, you know, a variable, or it's going to be a class. This variable E is going to be a class. And what is the type of that? Well, it's an A. What is templated? What is the type of that A that's templated? It's a float. So really, this is actually an A that has a float in it. And I'll show you that in a second. Okay? So let's run it again one more time. Just, you know, make sure no errors are coming out. So the way we kind of explore this is let's just kind of output some things. So it's public, so I can see out. So let's just go ahead and do cout u.e. Well, they don't have anything in it right now. Let's make a constructor. And this constructor, I want it to load. No, let's make a constructor yet. We'll manually load it. Because I don't want to show you functions yet inside of there, just variables for now. So we'll just say something like u.e gets 22. Well, let's do 22.5 so you can see coercion happen. And then let's see out UE. So you can see that 22 is stored in there because UE is a integer. And this is a float, or sorry, a double, so it gets coerced and it gets stored. Cool. What happens if I try to do this with V? Well, with V, we're going to get a segmentation fault probably, or just, oh, it doesn't even compile, because V is a pointer, right? So this is a pointer variable, and we're trying to assign a number to a pointer variable, which is the equivalent of trying to change the address to be literally address, whatever 22.5 is, even as an address, which doesn't make much sense. But I guess in theory, like 22.5 is a 64-bit representation of just zeros and ones, whatever the IEEE standard for that is. So that could be an address. So that's not as much of an issue for the compiler as the issue is in general that to protect you, it doesn't let you directly assign numeric addresses, just addressing it. Doesn't let you assign any address to a pointer variable unless you force it using things like f-permissive. So yeah, that's not gonna work. What I can do though is I can make it point to the E from this one, right? So let me put this back in. I could make this variable address be the address of E from the UE. Oh, also the fact that that was totally backwards, but yeah. So that. Do I need parentheses? I don't think so, but I might. Let's see. Oh, semicolon. Okay. So if this is okay, in theory, I should be able to see something like this. Change this to 11 and see if that changes. Yep, okay. So let me explain this. So v, the variable e here is no longer just, well, it's still a variable, but it's not an integer variable. It's a pointer. It's an integer pointer, right? So one thing I could do to this is I could just like do a new call and then, you know, deal with it just like any pointer variable. I didn't want to bring that in here because I don't want memory leaks and stuff. So instead what I did is I just made it point to another integer variable that we already conveniently have, which is the one in e, in u. So I just said the address of ue, which is the address of this integer, store that address here. So now if I try to change it here, you can see it changes on e, right? Because we have that shallow copy, basically aliasing. So yeah, you know, it's a pointer here. Let's keep going to the next one, which is the string one. So for that one, I can say something like xe gets hello world. And if I run it like that, damn it, semicolon, then you can see hello world. Okay, moving to the more interesting ones. So for those, ye is our object of a. So if I want to access its member, I just use the member access operator and do e. So if that one, and I can store, let's just say 22. That almost spells yeet, which would have been weird, but fitting for templates. So you can see if I run it, I can just print out 22 because that's what's storing in there. And the same story for the flow, you know. The flow is basically at z e e. Let's store 22.555. And you can see 22.555 here. Okay, so you know, it's okay if this is kind of weird to you. It's fine. Every time I see that, it's weird to me. The important thing is focus on this example first, okay? So you have a templated class, and you're basically saying that this variable can be whatever you want it to be, and you will tell it when you do the actual instantiation. In this case, you're saying it's an integer. So now this is the equivalent of saying that this was an int. That's literally what it's happening. It's just replacing it. With the string, same thing. This one's just replacing with a pointer. This one's replacing it with an actual a. So this would be the equivalent of you having something like this that had an a in it. However, this would not compile because it would be like a like an infinite sort of like Inception. Like it would be like a class inside of a class inside of a class inside of a class, right? This would go on forever. You can't do it. You can do it if it's a pointer, because then it's not allocated and just an address you're storing. But this just would never compile. Like it just be there's an error you get. It's called incomplete. Yeah, incomplete type. I think that's the error. So the reason why you can achieve it this way is because even though you have the word a in here and it feels like it's a class A, it's its own class that is kind of made on the fly when it knows that it's an integer. So you're still making technically, well, not you, but the compiler is still making all these different classes that you wanted. But that's being done by the compiler. You only have to worry about one of them. So no issues trying to maintain all of them and whatnot. So it's very, very good that you're using templates. Like it's powerful and nice. So that's what's really happening here. So that's why you see something like this. So play with this on your own and explore it and get a feel for templates. And I think that will be ultimately the best way that you can kind of succeed with these with templates. Is just keep playing with it. Okay, let's go ahead and add in functions inside of this. Okay, so first things first, let's just kind of, let's do a setter and a getter for like E. So let's do set E, and so you can't give it a specific type here, right? I can't say like I'm gonna make this an int x and then do something like E gets x, right? Because we don't know what E is. It could work, but it could also not work, right? And the code will compile. Actually, this is a good example. Leave this as this. This is a good example because like if I comment out the string example, and yeah, I think that's the only one that causes like issues, then this will work, as you can see, because what's happening here is when E is an integer, well, everything is smooth because this is an integer. And in the one case where it's not an integer, where it's a float, then all that's really happening here is that E is getting replaced with something that is an integer, which, you know, like, so like, let's just say I call this with, what is this one called? Z. So let's go ahead and down here, let's just say I say Z dot set E 56.54, I guess. So if I run this and then I run this line again, hopefully I don't have a lot of output that this becomes confusing. Yes, I do. I don't know where this one is from. So let's comment out the yeet. Let's yeet that out, I guess. Oh, it's not compiling. Oh, match for operator equals. Oh, really? Really? Why? Oh, because it's a class A. My bad. So this is class A. So this is actually class A. So of course this is not existing. So let's actually take this back. Let's just modify. Let's make another class A. Let's call this one float. As for float, sure, why not? And then let's do f set E. And then do C out and line, and then everything else should be okay. So you can see here that even though I am trying to set it to be 33, it's only setting it to 3 because when you're calling this, it plugs in that int in here as the 33.3. It loses precision over that. So by the time that it gets stored here, it's already lost precision. Now, why did the other one not work? Again, because the E inside of this is actually an A. So I was trying to say A gets like 33, which is like confused because it's like, I don't know how to deal with this. You haven't overloaded like the operator, right? So if I went in and I overloaded my operators, and for the assignment and whatnot and all that stuff, then yeah, this would work out. But I don't want to do that right now. So what I can do though is I can edit the E inside of this. So what I really should have written here for this to work, my plan, is I can say something like z.e.set E. Now that one's actually a float. So if I go ahead and see out this again, then I should get a 55 right here. Again, loss of precision because this is an integer. So really, what I'm trying to get to is this shouldn't be an integer. This should just be the template type, right? Then you solve all these issues. You bring other issues on board, but you solve those. So now you have your precision back. So this will be 55.6, and this is 33.3. But you have to make sure that this is working. So if I go in and I try to call set E on a class A object, what's going to happen? Well, there's no dynamic variables in this class that I could see initially. So this should be like a, you know, even though it's a shallow copy, it's still okay because of no dynamics, so everything's gonna be okay. However, really you should be overloading the copy assignment, you know, operator here to be able to not run into those issues with a shallow copy. So like potentially I have one where I have an integer, right? So if there's a pointer, I mean, so like if this pointer had some dynamic variable in it, then you could run into issues here. So be aware of that. But for now, let's just leave it like it is and see if it works with the A. So let's just make another class. Or no, I'll just do it at the end so it doesn't get confusing. So for Z, which has an A float inside, I'm gonna do Z.E gets, or not get, sorry, C dot set E, and I'm gonna pass it in an object of A, which is going to be, well, it has a float in it, so I'm gonna pass it that F, which is also a float, and I think that should be okay. We'll find out, see if it compiles and runs. It does run, cool. Let's change it to U and see if we get an error, because I'd rather start showing you the error first. Okay, so let me show you why this doesn't run. So in this case, I'm calling set E, so it's calling the set E function on a with the template being resolved to an A class, right? So it's that A float that exists inside of Z. So this is an A float, and so I am trying to pass in, when I do U, an A int, right? So they're different classes. They're completely different classes. They might have the word A in it, but inside the system, they're completely different classes. Which you can see here by it says cannot convert A into a float. So it gives you an error, massive error, because it's just like I mean, you might as well call the one class like Tony and the other one like Jane, because like they're completely different classes. So it's like I don't know how to coerce one into the other one. Like yeah, weird. So, however, when I did F here, then it's okay because they're actually both floats. So then there's no problem. It runs smooth, everything is great, F is good. I can even, you know, print out what is in it. So like I can say something like cout C.E.E, and this should have whatever was in F earlier. So I think it's a 33, right? Yeah, 33, which is what we stored up here. So you can see that copied over. This is a shallow copy, which again, all copies are shallow unless you make them deep, but that's not a problem unless you're using dynamic variables. That's when really the issue of shallow versus deep comes in. So yeah. Try to pop my ears. Okay, so that's enough for the set E. Let's do the get E. Return E. All right, so by the way, this issue that I was talking about with the A float versus A and stuff like that, that doesn't show up unless you actually do the function call with the wrong class, right? So that's what I'm saying. Like, this code is syntactically correct. Whether it's semantically correct or not is up to what you're trying to make it do versus what it's doing. So, and you won't really know if you have that semantic error unless you actually try to call it on a scenario that's not sort of you didn't think about it ahead, and the code isn't prepared to handle it. Which is again okay because, like, you get the error at compile time, so you'll be able to fix it. 100% of the time, you want to get the errors at compile time and not at runtime, because compile time errors easy to catch because the compiler catches them for you. Runtime errors, not so easy to catch because they may or may not happen, and they could literally not happen for like 10 years, and then the day after they happen, and you're like, darn, now I gotta push a patch out. So yeah. Okay, so with the get E, we have a return type of the T, and we're just gonna return E. So let's try it on the F. So if I just want to say cout f dot return E, which is get e. And that should print out the 33.3, which is this one right here. I'm gonna comment out. I want to just, you don't get confused with that one, but yeah, it's right here. So that works just fine. What I want to get to with this one is like, suppose you want to make it outside of the class. Because notice, like you're making a template function here, technically, but you don't have to write the word template, right? And I kept like preaching like, oh, you got to write the word template every time. You're not writing it here. Well, technically you are up here, and it's sort of applying it to this. However, suppose that you wanted to make this get e function outside of the class, right? You know, because you're doing your header files and your implementation files and all that stuff. So if you went to my office, I have a picture there of my dog, and it says, my dog says like, I write all my code in main. It's like I'm not a fan of writing 10,000 files for tiny examples. For big stuff, yes, but like school stuff is so tiny. But people love just like splitting it into 50,000 files. It's good practice, you know. I respect it for what it is, but like if you're only writing 1,000 lines of code, splitting it into 20 files, I don't know. Splitting it into 2 files, maybe, if even. But like, don't go into, you know, do not become that person that like makes. Don't be the Java programmer that like has like 1 billion files, because every class in Java is its own file, and that's why I code Python. But yeah, okay. Anyways, a little tangent, but yeah. So you know, keep that on one file, but you can still separate like your class declaration from your definitions and things like that. But just, yeah, don't go over excessive with that. Follow homework assignments requirements though. I'm not trying to overturn what the requirement said. So if you want to write your get e function outside, then it's not enough to just go and do this. Like, I'm pretty sure you're gonna get an error returning it. Let's look at that error. Oh wait, well, whoa. Okay, first things first. You know, scope resolution operator. Okay, now let's get actually the errors. So the errors that we can see is invalid use of template name without an argument list. Argument list for class template A is missing. Identifier E is undefined. So this one already tells you that it's not locating the class. It's like, yo, where your class at, kind of thing. So yeah, this won't cut it for a templated class. It needs to know that this T, you know, what this T is, like it's what template variable it is, and like it just gets really confused. So first things first, you need to write that word template class T. I told you won't get away with that. You can do type name if you want instead of class, but I like class. It's shorter, less writing. Like type name is like type name, so like that's what, 8 characters. Class has 5 characters. That's 3 finger keystrokes that I've saved, and yeah, it can multiply a lot. And you don't lose any readability, which is the other thing. Don't go too far with shortening code that readability is lost. That's the 3 main things in writing code is readability, writability, and reliability. You learn about it in 326, but like you don't want to sacrifice one, you know, too far because you're writing code really short. It's you know, you could have the shortest code in the world and still be the useless code in the world because only you can understand it. There's a fine line. You know, don't make overly excessive long code. Templates, you know, you want to shorten your code. But shorten code that actually should be shortened. Don't shorten code that shouldn't be shortened because no one else will be able to maintain it. Unless, of course, you're trying to retain your job. And then somebody might help to make your code a little hard to read because then they can't fire you. You know, it's like unethical life pro tips. Okay. Don't do that. Don't tell people I told you to do that. Okay. So, yeah. So you write that, but that's not enough. If you try to run this, you're still going to get yelled at by the compiler with the fact that, oh, it's actually, this is a really nice, like being a nice yelling by the compiler because it actually tells you how to fix it. It says name followed by : must be a class or a namespace, and value use a template with an argument list. So what this is saying is, remember when you make a class, you got to tell it the type. You got to do the same thing here actually when you're making the scope resolution operator. However, you're probably thinking like, but like, you know, this defeats the purpose if I gotta name a type here. Like you know, I want this to be templated. I understand you. It's okay. We can work this out. All you gotta do is put the type that is here, the variable there. So as weird as this looks and sort of kind of redundant, if you do that, the problems will be solved, or at least they should be solved. What have I done now? Need type name. Do I have to write the word class T? What? I remember that. Having to do that. Hold on. I broke the code now. Have to do anything else? No. It should work. Why is it not working? Hold on. Let's look at the actual compiler. Need type name before that. I don't remember having to write this word in here, but I guess it's been a while since I did temp because I'm a Python coder, but that's not it. Hold on. Let me check. Oh. Wait. Yeah, okay, my bad. This should be on this side. There we go. Yeah, okay. Sorry about that. So, remember, when you're writing a class, let's call it like class Y, and you have a function in it. If you're writing a outside of this class like a function, what do you put first? The return type, right? You put like void, that's your return type, and then you put the class name, scope pursuit operator, and then the function name, and then you write your code, right? So we all know how to do that, but like once you start throwing in all these weird characters with the templates, like I forgot about that. So I was putting it backwards, right? I was doing the equivalent of me writing this line of code. Instead of writing it like this, I was writing it like this, which makes absolutely no sense. Like you see that and you're like, what the hell are you doing? But I was looking at the T's, and there's a lot of T's in here, and yeah, that threw me off. So I'm sorry about that. Kind of freaked out for a minute. But yeah. So this is the right way to do it. So return type, which if it's a void, then the word void could be here. I'll do set E in a minute, and then we can see that. But if it's a template return type, then you just put the template variable name, and then put your class name, which you do have to put this inside because like you gotta tell it what the template is resolving to. You're like, I'm not telling it an integer, float, or whatever. I'm telling it that it's a template variable. So it's kind of like linking it and saying to be decided once we create the class object, and down here, and then you write your name. So okay, so yep, that does make your outside of the class function definitions kind of longer, but it's just the way it is. Let's do another void one. So let's bring this one out so you can see that. I'm gonna get rid of class Y now because it's kind of very randomly there. So template class T, and then this time we're gonna do this right. So we're gonna put the return type first, then we're gonna put the class name, which is A, put the type, which is just the template, scope pursuit operator, function name or variable name if it's a variable. And then you, well, if it's a variable, you don't have a return type, but yeah. And then what you want to do, so set E, so in this case, TX. And then, what was it? E equals X, right? So, that. Okay, and that's it. That's how you do it. So, I mean, it's still simple, actually. I mean, it's just that I screwed that up, but it's still simple on this level. Let's make it more complicated now. So now, so at this point in the video, you can see that we're at a 1 hour and a half. So we're technically on the second video of the week. I just decided to make it all together because it's just one topic and it's nicer. So you can pause it and take a break between days if you want, or watch it in one go. But ultimately, this kind of ends the template basics right here. You know how to do a function template. You know how to do a class template. That class template can contain template variables and template functions, which you see here. That's technically all there's to it. But there are some weird nuances which you already kind of start to see in here when you have a thing like a templated class instead of another templated class. Things like this start to get a little trippy when you do inheritance and whatnot. So I thought for the remainder of the time, for the second lecture, let's just kind of explore some of those weird issues so that it's better for us to explore them now, crash and burn, figure out how to solve them, than to, run into these when you're doing homework or you're trying to do a template in the real world and you're just stuck. As always, you should Google errors and find probably someone ran into the same error lots of times, particularly at this level of your career. So you can find answers online for that kind of thing. But it's still good to see some errors now, at least the most common ones. Which you kind of saw when I flipped those, so that's nice. Okay, so let's just let's start by expanding this template class and adding in a second template variable within the class. So I'm going to back this up so you have a copy of this. And templates are going to come into play for the rest of the semester, particularly when we get to linked lists, because we want to make a templated linked list ultimately. That's like the achievement of the class, or a templated stack or queue or something. So it's nice. So let's just get rid of clean up main. We'll make more template objects in a bit. We can leave those outside. Yeah, we can leave these. I'm just going to make them take less space so that we have more sort of space in the screen to show new stuff. Damn it, I keep erasing one too many times. Okay, so the first, and then just to get rid of this card function. The first thing I want to do is add that second variable, right? So I'm going to make another template. By the way, remember inheritance when you have to do like public every single time you do it, when you do multiple inheritance? Same logic applies when you're doing templates. You have to write the word class in front of each one, okay? So in this case, I got two template variables now. So I could use them however I see fit. So I could just, I could make another variable here like this if I want to, or I could make a function. Although, stick with variables, otherwise why you're using the class. Unless your function is to interact with the variables. So yeah, so like right now, let's say I want to make a function out of this. So like I want, oh, and by the way, let's add a constructor too. That'll be another interesting one. Let's add a setter for z. So void set z, or set for British, I guess. And then we'll pass in the parameter. B, I don't know, I'm just picking random letters here. Oh, well, here, let's do it outside the class, actually. So, template, class. So, first question of the, comes up. Do you just do this and call it a day? Like, would this work? If I just said, oh, well, I'm not using T technically here. So, I could just kind of run it with this one and then do like set C, and then just do U set C X. Technically, by the way, you don't need this here. It's, remember when you're if it's like if you're doing void set like I, and you just do this, that's more than enough. You can add in that variable if you want, like whatever the variable is going to be, but you don't have to. So, I would actually argue that this is more readable like that. But yeah, you do have to do it here though once you're actually, writing the full body of the function. But yeah, so like let's say you do something like this, and then you do z gets e, right? So this is the first sort of issue that you're going to run into, or not issue, but question that you need to like know how to approach, right? So we have multiple templates in the class, and you might be compelled to say, well, I'm only using one of them, so I'm just going to do this. And no, this is not going to work at all. In fact, you can see already everything's underlined, right? The moment that you added a second variable here, you need to go down here and like change all of these to match this definition. Otherwise, it will say that the class is not found and give you errors. So go in here and literally replace all of them. The second thing you're going to have to update to is this. You need to put both variables in there. So how do you create an object, or if I want to make an object now of this class, when it has multiple template variables. So if I want to make an object of A now, I can't just say like int, because there's two of them, right? And it's not going to be like, oh, well, it must be both ints. No, you have to be explicit. So like if I want to make both integers, then I have to do something like this. If I want to make different ones, like float and integer, then I have to do something like this. But I have to specify both of them. And similarly, when I'm making functions like this, I need to pass both of them like this, okay? And let's see what else. V has not been declared. Where did V come from? Let's see. Why is there a V here? I don't remember why I put that there. But yeah, I forgot. I don't know where that came from. But anyways, whatever. Oh, I see it. Well, that should have been like this. That's what I was thinking in my head. But then it became an X. Oh, yeah. See? More reason why you should just keep the type here. Don't put a variable name at that point. Keep just the type. Okay? So, yeah, this works now. So that's the first nuance you're going to run into. If you're using multiple class templates, you need to put both class templates everywhere. Okay? Unless you're putting things inside of here. So this is like the golden zone where you don't have to think about all these nasty stuff. Everything is not here. Because those are inline functions, right? But you shouldn't be doing everything inline, technically speaking. So there's that. Then there's, of course, throwing the word virtual into templates and all the nastiness that they can bring. Particularly when you're dealing with polymorphism and inheritance. I don't think we're going to go that hardcore into this. But let's do some inheritance at least. Okay? So yeah, even if your function isn't dealing with both template variables, because the class is, you have to pass them both. Okay, so also, I'm curious, what happens if I flip these? Like, does that compile? Does that really get confused? Incomplete use. So I guess it just gets confused. But what if I make them both integers? Like, will it be okay? Like, will that slide through? Nah, it won't. It just yells at me. Okay, that's good that it yells at me. So yeah, make sure they match the ordering too, so that weird things don't happen. Okay, so where's that underlined? Okay, let's go on to inheritance now. So let's try to. So let's let's just do a basic inheritance, and then let's do inheritance and actually add an extra template variable. Okay, because it starts to get real nasty real fast. So we're going to do class B, which is going to inherit publicly from class A. Okay? So, red flag, already, if you try to compile this, it doesn't compile, right? You get some issues. First of all, is you got to add all that template fanciness to the inheritance. So, go up here and put that in. And then also here, anytime that you're dealing with you're referring to the class, like, name, it's not enough to just put the class name like this. You have to actually put, again, the TU stuff. That's why I picked single letters for these variable names, as you can see why. Okay, so bam. All right, so we got some inheritance done. So my dog is behind me. We got some inheritance done, and it'll work if we try to, like make an object of this. It should work fine. So like, let's just make it already instead of A. Let's just make it B. Run it, and you can see it runs. No problem. obviously, I mean, it's not doing anything, but it is running. Okay, well, what if we want to... Well, let's add a function just really fast. Just, you can see there's no big deal when it comes to just adding functions. Well, let's add a function, and let's add another function that modifies the template variable. That's when things start to get awful nasty. So I could just do like a void foo. No problem there. You know, I can like call foo and be okay. Okay, I gotta rename it. Otherwise that will bother me. Semicolon. Oh, we got a linker error now. Ooh, okay, good. I'm actually not sure why, but let's see it. Okay, so I gotta look what the error is here. So you probably have seen these kind of errors before when you were dealing with like header files or maybe even with virtuals, where it says like undefined reference. This is like a linker issue, so it's still just an error with your code. What is probably happening here is it's trying to call the foo function, but it never sees the foo function fully defined because you never write a body for it, right? So like it's kind of the same thing when you deal with virtual functions and you're dealing it. So that's a simple solution though. Just actually add a body for the function, you know, and call it a day. See? Good. It's good to refresh those kind of errors. I know a lot of people always freak out because it doesn't actually tell you much. It's like undefined reference, and you're like, huh? But it's just doesn't find a function. Because when you're just writing this, it's like you promise the system, like, hey, I'm gonna write this eventually, like, you know, using this code, but you never do, and so it freaks out. It's like I never saw it, so it can't compile. So yeah. Okay. So far so good. What if we want to modify the template variables? Okay. So let's do that outside. So let's go ahead and template class t class u. Okay, so let's call foo in here. So return type first, so screw up like I did, and then you might be thinking, okay, what do I do here? Like, do I put A? Do I put B? Well, you put B, and then you put the types, and then put the function scope precision operator, function name, and then what it does, which will just say yeah. Well, actually, no. Let's make it cool. Let's actually print out the contents of like E and Z. Okay, so we get some errors that was not declared in the scope, but we are inheriting, right? So shouldn't we have access to them? Well, I guess we should, but we are not getting access to them. So we might have to put in some scope resolution operators to resolve that. So let's try this and see if that fixes it. Yep. I mean, we're getting valid data because we never put something in it, but yeah. So, you know, already there you can start to see like that is not cool. What happens if I use bees though? Bees work fine too. Interesting. But it doesn't like it when they're alone, even though they're class variables that are being inherited. That doesn't happen with the non-templated like class, right? So it's kind of weird. Like, I could probably use the this pointer. And be okay. Yeah, I'm okay with that. But it just doesn't like it when it's alone. It just says it is not declared in the scope. And like, you don't run into that issue with a non-templated class. Like if I remove the templating from that variable, like here, let's just add another variable. Int v, okay? If I just go in and like see out v, oh, it's still giving me issues even though that one's defined. So it's just it has to do with the fact that the class is templated, where like it breaks it. You know, it breaks that functionality that you normally would have. So you either use the disk pointer or you explicitly put the scope of the class, even though I could put B or A and both work. You know, so like let's leave that in there. So let's do int B, and let's leave this B, and then I'll show you that you can do it with this. B, and then for this one we'll do B. So you can show all the different ways to access it, okay? Oh my god. So ultimately, these will all work with the disk pointer, with the scope resolution operator, but what will not work is just leaving it on its own. And I frankly don't remember why. I just remember that was an issue, and that's why we're bringing it up. So yeah, like again, these are the nuances of templates. My guess is that the compiler tries to autofill for you the class name, but because it doesn't have the template flags, it complains. Maybe. What happens if I try to change? No, that won't work. I can put an A in there. So yeah. Okay, so just another thing to be aware of. If it's not working, try adding the disk pointer or try adding the scope resolution explicitly of the original class, parent class. This is not an issue if I have a variable here, if I recall. So like if I put in an int y, then I can just see out y just fine. Let's add some numbers to this because we're getting like a lot of random data. So like let's say b dot. What are the variables? I forgot all. So we got an e, a z, and a b. All right, so e. Okay, whatever. B dot. Oh, semicolon. I'm trying to figure out. I guess they're all integers right now. Well, no. Z's a float. Let's store something that's floaty. And then the y is just hard-coded to be an integer right now. Which we'll change it to a template variable in a minute. So, we're still getting random data in one of the variables. V? We set V? Oh, the what is probably, yeah, the V. We never set the V. Yeah. We're actually not using the Y yet. So. Oh no, we are using the Y, so let's leave the, so we'll just add in the Y as well. Okay, so now we got some valid data and all of them. And then also we probably should separate them because they're all being kind of on the same line. So lines, and line. Oh, here, save some space and put it there. Also, this bothers me. I don't like it when the little things there because I want to line them up like that. Yeah, okay. One more in line. Okay, so we can see 55, 22, 11.11, and 44. So you can see, like I said, like you have no problems with this y here, like referring to it. It's only the parent ones that you have to like do the weird syntax for. Okay? Hopefully all this stuff isn't scaring you away from templates. Like they're really powerful. It's just, again, great power, great responsibility. You have to be more careful than you normally would be. But no fun making this an integer. Let's make that a template. So like, okay, we're inheriting templates already, but what if we want to add an additional variable to the derived class that's templated? Well, you could like make it one of the parent templates, like this. I think that will work just fine. But that's no fun. Like, that's just using the template that exists. Let's make it one that is like a brand new template variable for a brand new type, like a third type. Okay, so UV, so I guess UV is the next one. And then now I can go in and put that there, okay? However, now we gotta update the code here, right? Because remember, they all have to always match this. So this one, not the parent ones, but at least this one. So now this one is going to have a B here, and things are, they're gonna get nasty now. This is probably gonna yell at me. Let's leave it like this and run it, see if it runs. Nope, we got 8 errors. Wrong number of templates, request from member Y. So let's initially first try to just add a V to this and see if it works. Well, not that one. That one let's leave like that. But let's add a V to this one. Well, it went down from 8 to 7. Oh, we got to change this now. Make it another integer. And there we go. We fixed them all. So just to triple check, this shouldn't compile if I remove that, right? Yeah. Okay. And that was wrong number of template arguments. 2 should be 3. So at least the error is actually nice. It's like giving you a hint of like you gotta make it 3 because you made it 3. Class B now has 3 templates. So it gets even more trippy, you know. Like now, like if I get rid of all of this and just try to access Z, it should still give you errors. That is not declared, even though it's a derived class. So you still have to put in the name of the class explicitly. You could, if you really want to, also use the parent name to explicitly access it. Although at this time, I think this is better syntax than this syntax, but it's okay. Ultimately, although this might be just the cleanest one, frankly, to use a this pointer for this. And then for your local variables within the, not local, but your class variables that are not being inherited, you can still access it without anything. But I would actually go with the this pointer for all of them and clean up the code. Like this could all be this V, this E, this Z, and this Y, and this will be fine. But I'm trying to show you the different options there. I don't know why that is like underlined. There we go. Okay, so that's another sort of nuance that you have to think about with templates, with inheritance. But you know, it's easy. If you want to add more templates, variables as you saw, you just have to make sure that all the classes outside are defined like this. One thing I haven't shown you actually yet is, what if you want to access a variable outside of the class? Like let's make a static variable, a static templated variable. That sounds nasty, to be honest with you. Wait, can I even? Ooh, that's okay. Let's make a static variable first, and then think about the possibility of a static templated variable existing, which I'm not sure if you want that. So like, you know, we usually use like a counter for something, a static end count, right? I think that's the syntax. So if you want to initialize it, you have to do it outside of the class. And the syntax is always trippy and always gets me. Let's see if I get it right the first time. Well, now I gotta do the template stuff. Okay, here. Now let's do it in B for now. Yeah, make life easy. Okay, so for the static int count, I'm going to have to, if we forgot about templates for a second and we were just doing a normal static variable outside of a class, this would be int b colon count equal to 0. Actually, why did I set that? You can't do that. It will that will yell at you. Here, let's make it yell at us. I know you can't initialize them inside. It's like a big no-no. Forbids in-class initialization of non-constant static members, right? So to avoid that issue, you would do it outside, right? Like that. However, obviously this is not going to be enough, right? We need to throw in all this good stuff. But here, let's just run it without, so you can see it. Template class T used without template arguments. So that's actually a really good error. Like it's telling you literally what's wrong. You need the template arguments. So yeah, put them in. Okay, and now I run it. Oh, I need one more thing, which is the thing on the top here, which is put the whole template blah 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 blah. Nope. Template T after class. No, 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 no. I just need the letters, right? So I need the, like, where's this thing? This one. I hope you, you know, low key in my head, I'm thinking, like, you're all freaking out right now with all this code. But it's okay. It takes time. You get it, and then you're like, blah, this is easy. At least until you start doing weird things. But even like in 302, when you're doing like a templated ABL tree or something, it's not too bad. Like, maybe this is the level that it will get in terms of complexity, if even, depending on who you take it with. But yeah, TUB. So that one should be fine, right? No, that doesn't like it. Damn. See? This stuff is hardcore sometimes. T was not declaring the scope. So do I need this on top then? Well, it went down to, yeah, there we go. Okay. So there we go. Like, as you can see, I rarely use a template static variable. Well, I rarely code in C++ outside of this class these days, actually. Yeah, I said I love Python. Python, like, by the way, with templates, like literally you just do like foo a b, and like, yeah, they might as well be templates because like that function will take anything. It's like pre-templated, so like you don't even have to think about any of this template stuff. It just all happens behind the scenes, and life is good, and flowers everywhere, anti-gravity. So yeah, but yeah, there we go. We got a template variable. Or we got a static variable in a templated class. Now let's see if we can make it templated. I don't think, like, I don't understand how that even would work. Like, what that even means. Like, why would we want that? But let's try it anyway, okay? I know we shouldn't do this, but let's just try it. Let's leave this one in here. Let's make another one. We'll call this the y variable because why do I exist kind of thing. And we're going to make it one of the templates that we have. So let's do B. Okay, so let's see if we can actually get this to initialize. So maybe if we're lucky, this would work, and then it'll just assume that it's an integer because this is 0. What might be a double? Okay, let's see the errors actually in the terminal because these I'm actually curious about. I don't think I've ever tried this in my life that I don't remember. Error conflicting declaration of y. No, previous declaration of y. Oh, I wrote the word int. That should be a v. Here. Oh, it worked. It's like, oh, you know, bless the code here. Okay. Yeah, I mean, it must be, it's templated, and it must be resolving the template when you're doing the initialization. So in theory, if, I think it's an integer if you put a 0, but if I put like a 5.5, then it's probably a double. There's really no way to see that. Maybe there's an instance of, no, I don't think there is actually. Yeah, I don't remember. In Python, there's a function called instance of, and you can check what the type of the variable result is. So you can see if it's a double or float or whatever. Well, everything in Python is a float, by the way. Doubles are called floats in Python. There's no real floats in Python that is like C++ floats. But yeah, so yeah, it's just being resolved at this time, so there's no conflict. So I guess in theory, yeah, this is okay. I just don't understand why you do it, because you know what it's gonna be, and yeah, so it's one of those codes where like, yeah, you can do this, but like, will you ever do it? I don't know, maybe. And if you do, let me know. I'll be curious. So yeah, okay, that's statics, a templated static. I'm debating if I should delve into trying something with virtuals, but like maybe trying to make a polymorphic class and pushing the limit of what you can do with the templates, because like you know, if we have two functions and then the parent, no, but they will be the same return type. I'm trying to think of a scenario where like the compiler wouldn't know, because it's a virtual function, which function to call, and they're different, and they have different template variables, which would cause issues. But probably the template stuff is pretty strict. If there is something like that, it would just not let you compile it. So I think I'll save that for something you can play around with yourself if you ever run into that issue. Let me know though. Run into issue with virtuals and templates. I am actually curious to see the errors, and then maybe I'll make a video someday of that. Because I know for a fact we're gonna run into some weird, scary errors. But yeah, okay. Last thing is, suppose I wanted to make all the variables in B, instead of int floats and integers, to be like other objects of B. That means that each of these would become their own like set of B's here, like that. So like, you know, this could be int, and maybe this one's int float, and I'm scared to try anything else. I don't think we do any math operations, right? So I guess in theory I could do like a string, and be okay with it. They could all be different too, by the way. Like here, this one, or here, this one, so they're all different. This int, let's replace this with another B. Like that. So now, this line of code is literally a single line to declare a variable, which means every time you refer to this, like, well, no, not every time, but just trying to like read this out loud would be horrifying. Let's get rid of the spaces now so you can see what it looks like without the spaces. There we go. So this is the full line. Look at that. Just embrace that. You know, digest it slowly and kind of embrace it. Here, put it into 2 lines. That's just like oof, right? Let's call that variable. So these are the same. The top one and this one. I just kind of spaced it out on the top one to make it easier to digest. If it's even like easy to digest. But remember, each B has 3 template variables. So I'm saying inside of that one, the first template variable is another B that is made up of 3 integers, and then the B that's made up of an integer or float, and another B inside of it which is made up of an integer or float. So you have like 3 layers deep of this. Yeah, it's hardcore. I don't even know if this compiles. Oh, redeclaration. Let me make that a D. So there we go, compiles. So yeah, hopefully you never have to get to that level though, because that just means you should consider why it got here, kind of thing. Like fix the code elsewhere to not refactor your code or something. But yeah, so there you go. Now, in addition to showing you the basics of function templates and class templates, I went ahead and showed you some of the sort of nuances and errors that you might run into, and sort of really it's about knowing the syntax. It's all syntax if you think about it for templates. Like you know, how do the static variable? As long as you know the syntax, you can get it done. Whereas with other things, it's like you need a lot of like critical thinking. With templates, it's just really knowing the syntax. And if you know the syntax, then you can do it. But it can get a little tricky and easy to get organized with them. So you just have to be very careful with them. But still, they're really powerful. And if you are coding in C++, you definitely want to be using them. Particularly, understand that they exist so that like when you're using a library and you run into issues with the library and you start looking at that code and it's full of templates, then you don't just freak out and not follow. I didn't do a lot of examples with pointers, but the same rules stand with pointers. In templates, they work. I mean, you did see one example of that today, but I just want to emphasize that you have to be careful because of the whole shallow versus deep copy when dealing with templates, okay? So just remember, a template variable can be anything, including a pointer type. So like right now, all of these are actually data types, but like this could be, I could just randomly switch this to be a float pointer. And then like, you just have to be aware of that. Like if you're writing code and somebody can do that and they do it, all of a sudden your code might not even work because it's expecting an actual like static memory, not like dynamic. So all these things you gotta take into consideration when you're working with templates. So yeah, that's it. Templates in one video, albeit one that is worth the duration of the full of the full week. but still short if you think about it. So instead of making 2 hour and 15-minute video longs, I thought I'd just make a 2 hour 10, get everything, it flows instead of kind of cutting it off and then having to review. You probably didn't watch it in one go. That's fine, but at least you have it all in one place, one reference. Okay. If you want to see more examples of templates, I have previous semesters recordings on templates, like last semester's and whatnot. So you can check those out and see more examples and see more errors, because I know I did different things each semester nowadays with templates. Looking at my notes from last semester, which I try to keep around in case I run into issues. I did some pointer arithmetics when I was talking about templates last semester, I guess. That's neat. But yeah, I did some passing by reference versus passing by value. So that's something that I really didn't talk about much with the templates, but you might be interested in checking out. So if you want to check that out, you can look at the fall 2021 and see that. It's just fun extra knowledge. They won't go this in depth in the exams for that. So just know the core template knowledge and you'll be fine. Great. Well, that's it. I thank you all for watching. Stick around for the next video. We'll be looking at recursion. But until then, have a great day.